This quadrilateral is a square. A line segment is drawn from each vertex, dividing one side of the square into two parts of lengths 5 and 10. A quadrilateral is formed inside these four lines, and it is a square. What is the area of this square? First, let us consider the angles of the larger square, which are also divided into two parts by these four lines. We label them with numbers. Now, pay attention to these four triangles. Proving that these four triangles are congruent will help us a lot in solving the problem. We start proving the congruence of these triangles by examining their angles. The angles of the square are 90 degrees, so A1 plus A2 equals 90 degrees. Also, this triangle is a right triangle, so the sum of A2 and B1 is 90 degrees. Since A1 and B1, when added to A2, both equal 90 degrees, A1 and B1 are equal to each other. Now, we move on to the other triangle. The things we said for the previous triangle are also true for this triangle. B1 plus B2 equals 90 degrees, and B2 plus C1 also equals 90 degrees. Therefore, B1 and C1 are equal to each other. And now, the third triangle. C1 plus C2 equals 90 degrees, and C2 plus D1 also equals 90 degrees. Therefore, C1 and D1 are equal to each other. From these three equations we obtained, A1, B1, C1, and D1 are all equal to each other. On the other hand, if these angles are added to A2, B2, C2, and D2, they will be equal to 90 degrees. Therefore, A2, B2, C2, and D2 are also equal to each other. Now, we only need to prove that the sides between each pair of angles are equal to each other. This part is also easy, because the side we need is the same as the side of the square, which is equal to 15. The congruence of the four triangles has been proven. Now, it is enough to examine one of them and apply the result to the others. You may know that if a line segment is placed inside a triangle in such a way that it intersects two of the three sides and is parallel to the third side, it creates a proportion. For example, in this triangle, AF and EN are perpendicular to BF, so they are parallel to each other. The ratio of these two triangles can be calculated using the ratio of BN in the smaller triangle to AB in the larger triangle. Its value is equal to 1/3. If we consider this ratio as K, the ratio of the areas of these triangles will be equal to K squared, which means 1/9. This means that if this triangle has an area equal to A, then the area of the larger triangle is 9A. With the same assumption that the area of the smaller triangle is A, the area of the quadrilateral is 8A. Now, we apply this to the figure. Pay attention to this triangle. Its area is equal to the sum of A, 8A, and A. By setting this equal to the area of this triangle, we can find the value of A. And we just need to substitute the value of to find the area of the regions around the smaller square. Now, we find the area of the larger triangle. It is enough to calculate the square of one of its sides. We subtract the area of the regions around the smaller square from the area of the larger square to obtain the area of the smaller square. Finally, the area of the smaller square is 112.5. Thanks for watching this video. If you enjoyed this problem, don't forget to like and subscribe. Goodbye.